Hi there. Today we're going to learn about differentiating exponential functions. So since you remember, like exponential function, the standard equation for exponential function will be y is equal to e to the power of x. So we can see the formula here. If we differentiate this, so the differentiation of exponential function will stay as it is. Now from here, so this is our one of the results we're going to use in the question. So we can see the proof of this some other time, but let's see if we have y is equal to e to the power of b times x. So in this way, if you remember, we want to differentiate this. So once we're going to differentiate, so this, since we already saw here exponential, if we differentiate it, so it stays as it is. But the power here, you can see this time it's b times x. So once we're going to differentiate the power, so we will get b, because the differentiation of bx will stay become b. So then from here, b times e to the power of bx. So if you don't get directly, we call this we use chain rule. But if you didn't get directly, so what we can do here for such kind of questions, we can use the chain rule. So let's say our question was y is equal to e to the power of bx. So now what we can do here, we can use u is equal to bx. So in that way, our question will become simple e to the power of u. But this time you can see here, if we differentiate this, so the variable is here u. So in that way, we will differentiate with respect to u. So that's mean, again, if we use this formula, so this differentiation for this is the same as e to the power of u. But our question was in x, so we have to give our final answer in x, and we are supposed to find dy by dx, not dy by du. So in order to find the final answer, what we will do, we can use here the differentiation. So du by dx will be equal to b. But since you remember, we are trying to work out for dy by dx. So to apply chain rule, so this is another way of applying the chain rule. So what we can do, we can stretch this dy by dx, and another variable what we use here as u. So what we can do here, we can insert here du by du. So since if I cannot to understand that, so du and du gonna cancel out. So that's mean, again, we will get dy by dx. And since you can see now we have the values for both of them, since we know dy by du is e to the power of u and du by dx is b. So if you simplify, so this is b times e to the power of u, and then replace the value of u back, so which mean b times e to the power of bx. So let's have a look on these examples as we just discussed. So what will happen when we're going to differentiate? So dy by dx, so this is the coefficient, this will stay as it is. And once we're going to differentiate exponential function, so since what we learned, the formula is whatever the exponent function is, it will stay as it is. And then, but again, as you remember in the previous part we saw, so in order to differentiate this completely, so we're going to use chain rules, and then we need to differentiate the power. So the differentiation for 3x will be 3. So you just need to simplify this. So this will become 27 e to the power of 3x. Now okay, have a look on this example. Similarly, dy by dx, so now exponents stay as it is when we differentiate, so this will be as it is. But here, to apply the chain rule, so the when we will differentiate the power, so minus 4x plus 2, so the differentiation for this one will be minus 4. Similarly here, plus 7 will stay as it is since it's a coefficient, and then once we differentiate the exponential function, so it will be 5 minus 2x, and then from here when we will differentiate the power. So since you remember, like here the derivative of constant is 0, and here for this one what we will get, minus 2. So we just need to simplify this a little bit. So minus 4 e to the power of minus 4x plus 2 minus 14 e to the power of 5 minus 2x. So similarly, as you remember, like in the previous example, we used the u substitution. So you can do this question with u substitution too. So you can try if you want, if you didn't get in this way. So let's practice them. That's all for this. Thank you very much. Thanks for watching.